Hello everyone, good evening. I am Rica Luis T. Diaz, one of the reporters from Group 2. But before we start the discussion, I would like to apologize for my recorded presentation or discussion. It's because I have an important event that needs to attend. So now, let's start the discussion. So our topic for today is all about monoprotic acids, bases, equilibria. But before we proceed, let's get to know first what is monoprotic. So Johannes N. Bronsted and Thomas M. Lowry both independently developed Bronsted-Lowry theory of acids. Their theory states that an acid is a proton donor and a base is a proton acceptor. This idea of proton donor and proton acceptor is important in understanding monoprotic and polyprotic acids and bases because monoprotic corresponds to the transfer of one proton and polyprotic refers to the transfer of more than one proton. So, when we heard the word monoprotic from the kanaang naala na siya clue no, which is ang mono, which means kanaang one or single. So, for further understanding sa Bronsted-Lowry theory, I have here an illustration na makapa kanaang simplify. So, ang acid, it was said there that acid is the one who donates and base is the one who accepts. So, awa ang picture. Ang acid kay mo donate siya sa base. So, on the right side, ang conjugate base is 1 na lang ang inhabilis sa yaha, while ang conjugate acid is napunan siya og usa. So, therefore, a monoprotic acid is an acid that can donate only one proton, and similarly, a monoprotic base can only accept one proton. So next is, how do we know if it is monoprotic? So unsa atong timailhan nga monoprotic di ay ni siya. So monoprotic acids may be encountered during a chemical technique called titration. A titration is a process in which you take a solution with a known solution and use that to determine the solution with an unknown concentration. Look at the relationship between monoprotic acids and this technique. So, a solution, ara. So, a solution with a known concentration is added kaniyang nasa right kay added to the solution with the unknown concentration kaning nasa kaning pink. So, iyang giadan. Mao na siya ang titration. So usa na siya, muna siya ang way nga makahibaw ka nga kana ang monoprotic di ay na siya. Makadetermine ka if that one is monoprotic or that if it is polyprotic. Titrations as seen in the diagram provide a great method towards identifying monoprotic acids. The equivalence point in a titration is what clues you to with whether or not the given substance is monoprotic. So, what is equivalence point? Equivalence point is a stoichiometric value where the point in a titration corresponds to equal or equivalent amounts of acids and base being added. By graphing a titration curve, the equivalence point can be identified. So later mag-show ko og diagram. A monoprotic acid will only have one equivalence point. So now, why is this so? So we'll keep in mind that a monoprotic acid can only donate one acidic proton. So look at this diagram as an example. In this rotation, a solution of sodium hydroxide, mao ni siya ang base, is added to a solution of hydrogen chloride, which is ang acid. At the equivalence point, the acidic proton, the hydrogen attached to chlorine, and hydrogen chloride reacts at an equivalence amount with the hydroxide ion from the sodium hydroxide. There will be no net acidic protons or hydroxide ions left over. So, because hydrogen chloride only has one acidic proton to donate, it is considered monoprotic. Kay usa ra man ang proton, di ba? Ang monoprotic kay makahatag raman siya og usa ka proton. So recall that the number of equivalence points in the titration curve corresponds to the number of protons an acidic can donate. So given this concept, as well as the fact that hydrogen chloride can only donate one acidic proton, it makes perfect sense that this titration curve is monoprotic. Next is one way to display differences between monoprotic and polyprotic acids and bases is through a titration. So, which is mo to ang gipakita nako ninyo earlier, which clearly depicts the equivalence points and the acid or base dissociation constants. The acid dissociation constants signified by K sub A, and the base dissociation constant is K sub B, are equilibrium constants for the dissociation of weak acids and weak bases. The larger the value of K sub A or K sub B signifies a stronger acid or base respectively. So, I have here the examples of monoprotic acids. Monoprotic acids are acids that can release only one proton per molecule and have one equivalence point. So unsa man ni sila? They are sodium I mean hydrochloric acid, which is considered a strong base. Then the nitric acid is also a strong acid, sorry. Nitric acid is also a strong acid, and acetic acid kay this one is weak. So later on I will discuss unsa man pag-determine nga strong ni siya or weak. So on the other hand, monoprotic bases are bases that can only react with one proton per molecule. And similar to monoprotic acids, only have one equivalence point. So here is a list of some common monoprotic bases. So katong pod before kay katong mga gipakita na ko ninyo nga mga acids before kay mga mapunto siya ang mga common monoprotic acids. So sa base pod mao pud ni siya ang mga common monoprotic bases. So first one here is sodium hydroxide, strong ni siya na base, and also the potassium hydroxide which is also strong, I mean. Then last one is ammonia, which is considered weak. So, how to know if the acid and base is strong or weak? The strong electrolytes are completely dissociated into ions in water. The acid or base molecule does not exist in aqueous solution, but only ions. Weak electrolytes are incompletely dissociated. So, what is strong acids? Strong acids completely dissociate in water, forming H plus and an anion, while ang weak acids can only partially dissociate in water to give H plus and the anion. So weak acids include kanang mga gipambulit dila nila ko basahon kay kanang mark taas-taas na. So please take note that a molecule with a formula starting with H is an acid. So example katong hydrogen chloride. So ang formula ato niya is HCl. So mo na siya ang example sa acid. So now naka-determine na ta sa strong ug weak acids. Let's now proceed sa strong and weak bases na pod. So now that we already know sa strong and weak acids, let's now proceed to the strong and weak bases. So strong bases dissociate 100% into the cation and OH negative hydroxide ion. The hydroxides of the group 1 and group 2 metals usually are considered to be strong bases. While ang weak bases Like sa weak acids, weak bases also do not completely dissociate in aqueous solution. So most weak bases are anions of weak acids, and weak bases do not furnish OH negative ions by dissociation. Instead, they react with the water to generate OH negative ions. And that's it for my part. Mr. Celera will continue the discussion.